Theoretical recap. In Linux, a shared folder is a directory accessed by multiple users or groups simultaneously. Securing it correctly means applying the right combination of ownership, permissions, and special bits to ensure that only authorized users can read, write, or execute files within it, and that they cannot interfere with each other's work unless explicitly allowed. Key definitions you must internalize. Owner, the user who created the file or directory. Group, a set of users sharing common access rights, and others, everyone else. Permissions are expressed as read, R equals 4, write, W equals 2, and execute, X equals 1, for each of these three categories. The chmod command modifies these permissions, symbolically or digitally, while chown and chgrp change ownership and group assignment respectively. Two special permission bits are critical for shared folders. The setGid bit, chmod G plus S, forces new files created inside the directory to inherit the group of the directory rather than the creator's primary group, essential for collaboration. The sticky bit, chmod plus T, prevents users from deleting files they do not own, even if they have write access to the directory. This is exactly how /tmp works. Common mistakes include setting permissions too broadly, 777 on sensitive directories, forgetting to apply setGid so files end up owned by random groups, and omitting the sticky bit so users can delete each other's files. A well-secured shared folder typically looks like drwxrwst, owned by root with the correct group assigned. Workshop brief. You are a junior Linux administrator at a company that runs a small development team. Your manager has asked you to set up and secure a shared working directory called /srv/divteam on a Linux machine. 3 users, Alice, Bob, and Charlie, belong to the group devs. A 4th user, Mallory, exists on the system but must have absolutely no access to this folder. Your task is to configure this environment from scratch, apply the correct permissions and ownership, and then verify and document that your setup is airtight. Begin by creating the necessary users and group if they do not already exist. Use the appropriate user and group management commands to create Alice, Bob, Charlie, and Mallory, and assign the first 3 to the devs group. Then create the /srv/divteam directory and set its ownership so that it belongs to root and to the group devs. Think carefully about what the base permissions should be. The group must be able to read, write, and traverse the directory. Others must have no access whatsoever. Once the base ownership and permissions are set, apply the setGid bit to ensure that any file created inside /srv/divteam automatically inherits the devs group, regardless of which group member creates it. Then apply the sticky bit so that users cannot delete files owned by other group members. Log in as Alice and create a file inside the directory. Switch to Bob and verify he can read and write to that file but cannot delete it. Switch to Mallory and confirm she is completely denied access. Document each test with the exact commands you ran and the output you observed. Next, simulate a real security misconfiguration and then fix it. Temporarily set the directory permissions to 777 using chmod. Observe what Mallory can now do, and write down the risk this represents. Then restore the correct permissions and explain in your submission what vulnerability was introduced, and why 777 is dangerous in a shared context, not just theoretically, but based on what you actually observed with Mallory. Finally, audit the directory using ls/law and stat, and produce a short written report, minimum 1 page, summarizing the final permission and ownership configuration, the reasoning behind each choice, the results of your permission tests per user, the misconfiguration scenario and its remediation, and any difficulties you encountered. This report is part of your submission and will be evaluated as seriously as the technical setup itself. You are encouraged to go further. For example, use ACL's setFacle/getFacle to grant a 5th user read-only access without modifying the group structure, or experiment with UMISC to control default permissions for files created inside the folder. You have 48 hours to complete this workshop and submit your solution before the deadline expires. Late submissions will not be accepted. You are fully allowed, and encouraged, to consult all previous course materials, file manipulation, permissions, chown/chgrp lessons, the man pages, and any reliable internet resources. You may work alone or ask a peer for conceptual help, but the commands you run, the outputs you capture, and the report you write must be your own original work.